Hello, welcome to the latest demo for my custom programming language called Fae. I recently added enums, both standard traditional enum variants and rich enums, also known as sum types, or compiler supported tagged unions, depending on what terminology you want to use. I have a bunch of interesting little tidbits of feature scattered in amongst these behavior that solve a specific set of problems that I frequently encounter when using other languages with similar features. And I want to show off these features and talk about what problems they solve. As a quick demo, I have this program here called pets. And I'm going to run that. It's going to print out a bunch of stuff. The CLI for the compiler has greatly improved recently. And we have a bunch of stuff being printed out. Let's take a look at all of these. Let's take a look at all of this. Pretty bunch of stuff. I wanna drill down into some specific examples first, and then we can generalize out. I want to show off this enum here called pets, which has a cat or a dog or a snake. And all of them have a name, but the dog has an I-32 representing how many hours it's been since you've walked the dog last, and the snake has an I-32 representing how many days it's been since it's been last fed. And we can construct those down here pretty normally. Fae has enum inferment for variant construction, struggling to find a better term for that, where because I've annotated that this variable cat needs to be a pet, which is the overall enum type, when I go to construct this variant with the .infer variant infer enum base thing, it knows it has to be a pet, and so it goes, oh, it's the cat of the pet. I could also go pet.cat, and the program would still run if I were to type some garbage here. Of course, the compiler can be like, I don't know what that is. Expected enum pet has no variant named that because it expects that it will be a pet, and it has no variant named that. So we fill in Lola here, and if you notice, of course, the cat here does not have the name field because it's a shared field. We fill it in. Here we have a dog. We have a snake, which has their separate special fields as well as the shared fields. Interesting little quirk about how this is designed is that each of the enum variants is a separate type. It is a separate type. I don't know if I have a demo in this file for that. I could come over here and let's write a thing. Say fun adopt cat, and it returns a pet.cat. Ooh. Normally you go over here and say it's a pet, and I can say return cat and say the name is, what could we name this cat? What could we name this cat? Tink. I don't know. And when that is valid, we can come over here. Let's return here, and we can let cat equals adopt cat, and we can print string cat.name. It's not going to print a new line, but that's fine. So we have Tink, and this is fine. This is a cat. Sorry, a pet. But we could also do this. Now, the compiler's going to yell at us because it doesn't handle this case very well for the inferment. But I can say pet.cat, and it still works. But what's weird is that is a pet.cat. That is not a pet. That is the pet.cat. It's the actual variant as its own type. Now, this has a lot of very interesting knock-on effects, primarily around how you handle the size of these, how you handle the passing of them, but also how you handle the pattern matching on them. Very interesting stuff. But the main reason for this is a lot of times you need some sort of base enum type with some set of a feature of items in it. And you want to be able to pattern match on and then call out into separate functions. Into separate functions that do the things. And if you do something in like Rust, for example, I'm going to pick on Rust because I love Rust. I've written Rust for like 5 years now, primarily. And it's what the compiler's written in. If I pull up the IR and I go to, let's say state. No, let's go to expression. Expression kind. So here we have a case of where these features start to come in use. I have these expression kinds, which is the actual expressions I care about. These are the actual things that the code handling this enum actually cares about. But all of them need some amount of shared data. And so I have to create a separate type that then has all the shared fields, and then I have a kind, which is the actual enum itself. But then let's say I want to pattern matches, and I want to call out into separate functions that handle specific variants. I can't just do that. I have to define every single type, every single variant as a separate type, and then store them in the enum so that I can then go reach in, grab the shared fields or pattern match on the kind, and then call out into a different function that can accept the specific variant. You have to do this all manually, and it's not great. And the problem is also here, these separate separate types don't have the shared fields. In Fae, they do because they're just the variants. They're just the variants. We go back over here to the Fae code. This pet.cat is just a cat, but it still has the name field. It's the shared field. It's on all of the variants, and every single variant is its own type. Now, weird little quirks about that is construction of these gets a little complicated. Let's go back up here to this vet specialty thing I have. I'm gonna comment this out for now. I really need to make a little bit of a language extension for Fae, just so I have auto commenting. It's driving me nuts. But let's say I have let a equals vet specialty dot mammal. Okay, so we have this enum. We have a vet of some kind, and its specialties either in mammals or in reptiles. Okay, cool. This code passes because we comment out the return. It runs all the rest of the code. But if I ask Fae how big A is here, we're going to get a bit of an interesting result. Now, you can't technically ask the compiler for the size of an expression. You have to ask it for the size of a type. But we know that this is a vet specialty.mammal. See, we know that's what it is. So let's come over here and we'll return again. And we'll say print iSize. I don't know if I have that in scope. I don't. The printing mechanism is what I'm working on next. But if I go and I go say size of vet specialty.mammal, what would you think this is? Now, I'll give you a hint. The size of the tag or the discriminant in Fae is guaranteed to be at least a byte. That's all that the compiler guarantees you, so you can't have more than 256 variants right now. That's a reasonable limitation, I think, for this stage in the language's evolution. It simplifies some things in the validation and the code gen side, because getting alignment right for this stuff is annoying. Frequently you'll have larger than that, but the compiler only guarantees you 1 byte. So we could say this is probably 1 byte in size because it's got the tag. If you know where this is going, you're going to know that that's wrong. I misspelled it. That's fine. We get a 0. It has no size. Of course, Fae has extremely good, I say extremely good, I haven't exactly written like lots of real world programs with it, so there are definitely still bugs hiding in it. But Fae as a conceptual language has high support for zero size types. You can just create empty structs, and void is technically a value in Fae, which is interesting. At least to some odd things. I don't know if that'll stick around, but zero size types, cool. Why is this one a zero size type? Well, the compiler doesn't need to put the tag in it. We know it's a mammal because that's the type. We don't need to know what type of vet specialty is this. We know it's a mammal. That's the type of it. But if I come over here and I say, no, you're a vet specialty. Right, because we're... because, of course, we're asking it for the type, not the type of the vet. That's fine. We get the one because the one byte tag or discriminant, depending on the term you use. So, okay, how does this work then if I'm constructing a mammal, but I'm saying, no, you're actually a vet specialty? Fae has a set of type coercions, very limited type coercions. Currently, it is exactly two things. The handling of compile time, constant numerics, because you do variant constant math, and it will do that all at compile time, and then, like, check. They're like, oh, you did math that got too big, and then you can't assign it to an I-16 or something like that, right? Like, the compiler handles all that. And then it can infer, it can coerce that compile time numeric type to some runtime type. So you can, like, create a constant that just doesn't have a type. It's just a 5, and then you go use it various places, and it goes, oh, in this place, I am an F32. Cool, and it just does that. The other place is for enums, because if you want to support having each variant be a separate type, you need to be able to construct them as separate types, which leads to, how do you construct a mammal as a mammal, or how do I construct it as a vet specialty that happens to be a mammal? The way I've gone with is you construct the mammal, and then if you say, I actually need a vet specialty, the compiler goes, ah, I got you, and sticks a tag there. Cool. It's a little bit odd. This is the one spot. I say one spot. Transparent variants, which we'll get to, are a little bit odd, but they're important. They're necessary. This is an odd outcome. I think this is probably why more languages don't have this. Then again, I say that. I haven't exactly done a wide sweep of the functional languages. So for all I know, there's a subset of the functional family that has this. I don't know. I think most functional languages just have some types as unions of existing types, so that they are basically the example I had in the Rust code of each of the variant contains just another type that's defined separately. I think so, but so this is a little bit odd, but it is quite interesting. It also means you could technically use the variants as like zero size generic tags on other things, which is weird, but I don't exactly want you to do type level programming, or what's the term for where you like have a state machine in the type system? Anyway, I forget what it is, where you do like certain operations and it like gives you back the object, but with a different generic parameter, so that it's a different state in the machine. Weird stuff. You shouldn't be doing that in Fae, but it's an interesting idea. So, we have these shared fields. We have these not-shared fields. We have these enums. Again, here, we're constructing a cat, and then it's coercing itself to be a pet. And it's the compiler's going like, here's the tag. Cool. Let's say we want to access some of these fields. We already accessed a field here, but we knew it was a cat, so we could just access it because it was just a normal field at that point. Well, if I come over here and I return here, so we're only running that part of the program, and we print that cat name. Remember, this is not a .cat. This is a pet. This is an actual enum itself, not the variant. We're still going to get the name because it's a shared field. You can freely access shared fields on the enum without pattern matching it. You can just do it. because all of the variants have it. All of the variants put it in the same offset in memory. So just access it. Cool. I could, of course, do the same thing here. If I go here and I have the dog and I return and I say, I want to print hours since last walked. This is going to fail. Print I32. Again, actual printing facilities are my very next thing. But we could say dog.hours since last walk. And compiler's going to be like, I don't know what you want. There's no field called that on this type. What are you doing? Cool. But let's say we want to access that anyway. How do we do that? Well, we pattern match it. The simplest form of pattern matching in Fae is the is. I kind of stole this from C#, but that's fine. So we have a dog, and we know it's a dog logically because we can look at the code. But the compiler doesn't know that because we've erased that information and made it just the pet type. We want to specialize that back down. We want to narrow that back down and run some code if it is in fact a dog. How do you usually say, I want to run code in this condition? Well, you write an if. Okay. If dog is dog, what? What's happening here? I didn't exactly do anything special here. I said, if it's a dog, go run this. I'm still accessing the same variable. How's the compiler able to know this? Like, am I doing flow typing? Like flow or TypeScript or something like that? No, I originally wanted to, but I said I didn't really need to. What this is doing, this is not actually the same variable. It is, but it isn't. It has actually pattern matched dog. And because dog is a variable, which is a variable read, it's just the word, the compiler goes, let me just alias that for you. Because Fae is a language with variable shadowing. Let me just shadow that for you. With the same name, but with your pattern matched thing. You're not losing any information. You can still access all the shared fields. Now you've just narrowed the type of that variable. This is semantically the same as this, because this is the syntax in Fae for I'm checking is it a thing with this name, because that's the syntax for name : type. Cool, that still runs. If I come over here and I say this is the dog, compiler's gonna go, what? Because now we're no longer implicitly just shadowing that. But I can come over here and say the dog, and it runs. Cool. Cool. What if we wanted to take this a little bit further? What if I wanted to say if dog is dog and dog dot hours since last walk is greater than 2. Print string. The dog should be walked. The dog should be walked. Oh. Very cool. You can and after that and access the shadowed thing. You can't do that in Rust. No. You can if you're using nightly and you opt into the feature flag. I'm really looking forward to when they stabilize that. The syntax is a little bit obnoxious, but you can do it. In Fae, it's just the feature. It's just the feature. Now, let's say you wanted to nested pattern match. Let's open up another file real quick. Option of option. This is a file in the growing set of test programs for Fae. Let's run those right now. I've been invoking the Fae compiler directly because I have support for building a fully static redistributable bundle of the compiler and the standard library now. And it does not support running the compiler test because the user doesn't have access to the compiler test. They don't have the source code for the compiler tests. So if I go help, it's not in this list. I can let me just show you that. Statically linked. Very cool. Very cool. That's hard to do with LLVM. Technically, it's not fully redistributable because it currently assumes that LLD is in the path so we can link your executable, and it assumes that it can find a libc in the standard location to link to your program. The compiler will run and print help on any system, but to actually run it, it still assumes that there are some files in some specific locations. That's fine. Things to work out in the future. But if let me run I'm going to cargo run building the compiler, and I'm going to pass into the Fae compiler CT, which runs all of the compiler tests. And there's 92 of them. And this is one of those. And I'm going to go option of option, and it runs. Very cool. Very cool. Let's just come over here and return, and we'll see we're actually running this program. So we have a function that accepts a value, which is an option of an enum. And enum here is defined as having A or B. And of course, you can see here, out of order functions and types. Compiler does not care. The Fae compiler does not care. Now, this is not exactly, this is temporary because the Fae compiler, the Fae language is going to have first-class optional semantics. Right now, this is just a type in the prelude. It's just a type in the prelude. It has an unwrap, though, which is cool. It's just, and we'll get into this syntax in a moment. This is a transparent variant. We'll get into that in, like, literally just a minute. So, anyway, we have this function which accepts an option of an enum. Cool. And we call it some number of times with a none, with a sum of a none, a sum of A, and a sum of B. And you can see here the inferment works multi-level. So because this sum we know is going to have an option of enum, we can just dot sum again. Very cool. Very cool. But we want to print it is B in this case where it's sum of B. If value is sum, and value is sum, and value is B, print B. That's not as concise as some other languages where you could just nest a destructuring, and the compiler goes, ah, yeah, that's part of the pattern match. Fae has some interesting ideas about destructuring because part of the language is going to have anonymous types of various types, mostly just structs, actually. But the way destructuring is going to be imagined is it's going to be in the value location. So I'd say if I have some field in there, this would be field. That's how you would destructure. So I don't exactly want that to be part of the pattern match. I'm doing this as like one layer at a time. I kind of stole this idea of this approach to pattern matching in air quotes from Hare. It's a lot more limited. It's also a lot simpler because there are times when I have like written matches in Rust where I'm like, I need this to be part of the value, or this is part of the pattern, and like it gets a little bit tricky. It's not that bad, but I think there's worth in this approach, and it simplifies how destructuring is going to work in the future. So it's overall simpler. And you notice here, every time I do this it's shadowing val because it's the nameless is check. Now, the problem with doing this is not exactly exhaustive. We're not handling sum of none here or stuff like that. We're not handling lots of things. And let's go back to this pets program. I'm going to delete this. Clean up this program a little bit. There. So, if this is mammal method on pet. Pet is an enum. It's our enum with the shared field and then the not shared fields and stuff. And we want to return a Boolean if that pet is a mammal. We can match on something. If it's a cat or a dog, use comma, return true. If it's a snake, return false. Now, if I come over here, let's run this program. Running this program, compiler's happy. If I remove one of these, missing match arm for enum variant pet.dog. These are exhaustive. Now, one of the interesting quirks about only destructuring one layer at a time when doing pattern matching of enums, technically you can, when you actually destructuring as part of the language, you'll be able to structure multiple layers, but just as the values, it won't be part of the pattern matching. Anyway, one of the interesting quirks about this technique of pattern matching is that this match is guaranteed to be a switch, because all of these variants have an integer representing them. And so because there's no complex checking of values beyond just the tag, this is guaranteed to be a switch. Now the optimizer is not guaranteed to compile that down to a jump table. There are times where it will be faster not to. I think in this case, it would be faster not to because it's just 3 cases, I think. Again, that's the sort of thing that I'm using LLVM right now for that. These are the sort of things that LLVM figures out on its own. But what I'm feeding into LLVM is a switch. And that means that when you have lots of variants and stuff like that, it will actually compile down to the most efficient thing, and you're guaranteed that. This also means that if you want to do more elaborate pattern matching, you can just write a function. Because Fae has local functions. Returns true. Return true. And then here I can call returns true. And the compiler is happy with that. You can just define local functions inside functions, and they can inherit the type parameters of the outer scope. They can't capture, but they know how to handle all of the types, because like, oh, you're a method on a generic type, and then you have an inner function. It knows about your generic parameters and stuff like that. Cool. You can just write a function that you pass in some set of arguments, and then it returns a bool, and you do your checking for your quote-unquote pattern matching in there. It's not that big a deal. It's not that big a deal. And it makes it kind of more explicit. Like, I'm doing something more expensive here. Because let's, for example, I open up the tokenizer for the compiler, and I scroll down here. I'm doing a fair amount of pattern matching here. And even doing some if checks on these. This is how I fix the pre-C++ 11 thing where you have to have a space between. Fae also had that bug, but this is how I fix it. White space. Yeah, so some amount of this is doing complex things. This is not exactly trivial. Like, this is not a switch statement. This is an if-else ladder. This compiles down to an if-else ladder because that's what it has to do. So in Fae, you have to write an if-else ladder, and it's pretty obvious that you're checking every single thing until you find the thing. That's an interesting little quirk. That it's a little bit clearer, like, performance-wise, what it's actually compiling down to. I think that's pretty neat. That's not exactly the reason I designed it that way, but it's pretty neat. So I think it's pretty cool. So we've covered is checking, and of course if it's just a normal enum, normal in air quotes, it's just technically this is also aliasing specialty as a vet specialty.mammal. Doesn't matter. If it had any shared fields, you'd still be able to access them. So I'm pretty fond of this, actually. It works out pretty well. Here's that, that and thing. I really like being able to actually do that, because the number of times in Rust where I'm like, I need to pattern match this, I need to if let this, and then I also need to check if one of the fields has a specific value. And you have to nest it. You have to go another indentation level in. And I hate that. That's part of why methods are inline. Not inline. They're just in the root scope of, the scope of whatever you defined that type in is the scope that you define the methods in. So it's not indented another layer in. It's not inside the type definition itself, or it's not inside an impl block. It's not indented another further. So you can fit more amount of code on screen without worrying about, oh no, is my formatter going to wrap this weirdly? Of course, the Fae formatter is going to be better about that, because it's going to be less opinionated about, oh, you have to indent here. Not indent here, you have to break here and stuff like that. But anyway. And I'm quite fond of this. Oh, let's talk about, if we jump back into option of option, you notice we didn't exactly access any fields on these aliases. In all of the previous examples, we would have to go like, if value is sum and val.value is that, and then val.value is b. If we're imagining that it's defined as something like enum option t, we say none and then sum value t. If that's how it was defined, that's how you would have to write it, is you have to dot. But you don't have to. Why is that? Why is that? Well, let's go back to the prelude and let's look at the definition. I said I was going to talk about this. I kind of got distracted, but we're talking about it now. This is a transparent variant in that when you pattern match on this variant, it doesn't become option.sum, it becomes t. The variant is transparent to the data it contains. This is where this is an actual type. You can't put fields in here. You can't have multiple fields. You can't have visibility control. This is just a type goes in there. And that's what you have. That's it. When you pattern match on it, you get that type. You don't get the sum, you get the t. So if we come back over here, and pattern match val, if val is sum, value, val becomes this. Not sum.option of enum, option of enum. It just becomes the type it contains, so that you can do stuff like this. If I go into option of, do I not have another option? Oh, right. No, let's go into some of the standard library real quick. Let's say I go into file. This is a file type that we wrote in a previous demo video. It has been cleaned up a little bit over time, as I have added more features to the language. Again, here's that constant numeric type inference. This constant does not have a type. It's just a 20. And then when we use it over here, it goes, I'm an I size in this case, because it's an I size, and it coerces to that. So it just works. And here I think that becomes a U size, I think. But here we're reading until new line into a buffer of bytes, which is the list. And how we do that is we read until we encounter a new line. The compiler technically, this isn't very robust to reading past the new line, but that's fine. This was written for a very specific use case, and these are the sorts of things that evolve over time. But we want to say if the last thing in the buffer is a new line. Oh, look, we have binary character literals, because character literals in Fae are code point literals, and they are U32. They are not a character liter. They are not a char. They're not a byte. They are a code point. But here we're saying, yes, it actually is a byte. And the compiler makes sure that it's actually a byte. But we don't know if the buffer we actually read anything and the buffer contains any value. We don't know that. So buffer.last, if we go into list, buffer.last returns an option. If self is empty, return none. Value is that, return it. Cool. Very cool. Now, we can just say if buffer last is last sum, if it's a sum, and last is the new line, we can return. That's pretty cool. Because the last here becomes the byte. It just becomes the byte. It's not sum.byte. You don't have to come over here and say last.value or whatever you would call that field. It just becomes it. It just becomes it. So you don't have to structure it. It just is. It just is. Cool. There's still questions to work out, like I pass you an option.sum. How do you get the field? I probably should have a dot value on there. That's fine. I'm quite happy with how this turned out because it's useful in a large number of situations, and I constantly hit upon problems where I need shared fields or I need to be able to handle a specific variant in a function. I'm constantly hitting that. And like just about every single enum in the Fae compiler itself manually does these things. So just have them as language features. And I think that the value of these features outweighs the complexity of, like, I construct a variant and it is just the variant, and then it has to coerce to the greater enum value. That's fine, because you're not very often assigning an enum to a variable. You're usually putting it into a field. You're usually putting it into an argument. You're usually passing it somewhere. And when you do that, it's entirely transparent to you. You just say dot, whatever the variant name is, and then whatever the fields are. And the compiler goes, yeah, I got you. Pretty cool. I like it. Again, everything in language design has upsides and downsides. I think this hits a pretty good midpoint that delivers the features I want with minimal complexity. And that's part of what Fae is. Hitting that point where the ratio of value to complexity is very high, where you can do lots of useful things with limited complexity. And I think that this is a fairly simple way to do this, because, I don't know, I've been writing demo programs and test programs, and it feels pretty nice to use. I'm rambling. I should probably end the video here. Thanks for watching. I appreciate if you made it this far. I like talking about language and compiler stuff. I plan on publishing the code for Fae soon-ish. My next demo video will probably be string formatting for printing and stuff like that. I have a very interesting unified technique for that I think will be pretty cool. Steals from a couple other languages, mashes some stuff together, and I think provides a fair amount of utility for fairly low amount of user complexity of like how much you have to type or think about, and fairly high performance where you doesn't just like start allocating stuff. So, but we'll see that then. Alrighty. Thanks for watching.